Okay, so today we're going to be using calculus methods to do optimization problems. So it says to find solutions. This is our goal, to find solutions to problems that require an optimal solution. What's optimal mean? Best, yeah. So we want to find the best solution, the number that best works for the problem that's given. So here are the steps we can go through. We're going to need a primary equation. This is the equation that we want to use to maximize or minimize. What is it we're trying to do with the situation? Do we want to have something that's the highest or something that's the lowest? If we're talking about profits, we want to maximize. If we're talking about cost, we might want to minimize. We may need to insert a secondary equation into the primary equation in order to have a single independent variable. What this means with single independent variable is we can't have x's and y's. Everything has to just be an x, every variable that we use. So we're going to have to make that happen. Determine values for which a stated problem makes sense. If we're talking about the number of items we're going to produce or the amount of fencing we're going to use, we're not going to be able to use negative numbers. So if we get a negative answer, we know that doesn't make sense. Use calculus techniques then to find the max or the min. Let's look at the first problem. It says find two positive numbers whose sum is 140 and whose product is a maximum. Tyler, give me two positive numbers that add up to be 140. Okay, so 110 and 30. If I multiply those, I get 33 with two zeros, 3,300. So if these are my numbers, this is my product. Okay, can anyone come up with a higher, with two numbers that have a better product that add to be 140? Somebody give me two more numbers that add to be 140. 140. Okay, 140. So if I multiply those two to find the product, that's going to be a 4 with three zeros. So that's 4,000. You did better. 100 and then 40 gives us a higher product. What about if I use 80? What would it be? 80 and, what's the other one? 60, right? So 80 and 60 would give me a product of 4,800. That's better still, right? We don't want to have to do this, though. We don't want to have to check every possible pair of positive numbers to find out which has the maximum product. Now, what if my first number is x? What am I doing to find this second number? How did we find 30? How did we find 40? How did we find 60? Olivia?
Well, I was going to ask if I could notes.
Oh, yeah. Come on up. How do we do that then? How do we find the other number once we know one of them? Yeah. Good. So here's what we're going to do then. We're going to say x equals our first number, and she's right. The second number then is going to be 140 minus x. We don't want to call it y. We want to have two numbers in terms of x. Here's our first, here's our second. Now we read the problem again. Two positive numbers whose sum is 140. We've got that. Those are our two numbers. The product has to be a maximum. So now I have to say the product of these two numbers. Product means multiply. So x times 140 minus x. That's going to be our primary equation that we want to maximize or minimize. So now I'm going to go ahead and multiply it. So it's 140x minus x squared. I know this is a parabola that opens down. Okay? It's a parabola that opens down. At the highest point, what's the slope? 0, right? So I'm going to have to take the derivative to find the slope. 140 minus 2x. And what would I set it equal to? What do I want the slope to be? 0. So set it equal to 0. Solving this, I get 2x equals 140. X equals 70. Now, we have to make sure that that's going to give us a max. Here's the way I can do that. If I take the second derivative, what's the derivative of 140 minus 2x? Negative 2. That's a negative on my second derivative. That means that we're concave down. If we're concave down and that slope is 0, that proves that we have a max, doesn't it? Because it's a concave down and we have a slope of 0 at the critical number. So therefore, that's a proof. That proves that wherever that critical number is, it's going to have to be a max. So now finding our numbers, our first number is going to have to be 70. Our second number is going to have to be 140 minus 70, which is 70. So those are the two numbers that will add to be 140 and that will multiply to give us a maximum product. Okay? All right, let's look at example 2 now. The product of two positive numbers is 192, and the sum of the first plus 3 times the second is a minimum. This is a harder problem. All right, so let's kind of think about what's going on in the problem. So I need two numbers that have a product of 192. So I could do 2 and 96. I could use those two numbers. I could use 4 and, let's see, 4 goes in there, 4 times 48. Okay. It says that the sum of the first plus 3 times the second. I don't even really want to figure these out. It takes too long. I'd have to see what's 2 plus 3 times that. What's 4 plus 3 times that. And I want to have a minimum when I do it. How am I finding the second number? What am I doing with the first number to find the second? If they had to multiply to be 192? Divide, right? So if I say my first number equals x, then my second number is going to have to be what? 192, not minus x, but divided by x. Good. So there's my first number and my second number. Now I need my primary equation, the one that I'm going to maximize or minimize. And it's the sum, so I say sum equals the first, which is x, plus 3 times the second. So that's the problem that I want to minimize. So simplifying, the sum is x plus, this is 576. And if it's 576 over x, it's 576x to the negative 1, right? So I have to get this derivative now. So I take the derivative of x is 1. This is going to be minus 576x to the negative 2. If I'm trying to maximize or minimize, what do I want the slope to be? 0. So I have to set the slope equal to 0. And I'm going to go ahead and write it like this now again. So I'm going to take this over to the other side in order to solve. I'm going to cross multiply. X squared equals 576. I'm going to take the square root. Anybody know the square root of 576? It's 24. Okay, so I really get plus or minus 24 for x. Now, this is where I want to look back and see what my reasonable answers are. Is it possible that negative 24 could be my answer? No, it says I have to have two positive numbers, so I can throw out the negative 24. But I do have to check and make sure that 24 is going to give me a positive answer. Give me a minimum. So when I take my second derivative, this is my check. The derivative of 1 is 0. Negative 576 times negative 2 is going to be positive 1152, I believe. X to the negative 3 now. I really don't even care what this number is. All I care about is that it's positive. If I plug 24 in, it's positive. If I have a positive over a positive, that means my second derivative is going to be positive. It's concave up. So where I have this critical number, if it's concave up, where I have the critical number, is that going to result in a minimum? Yeah. So now I've just proved that 24 is going to give me a minimum. And you guys don't have to do the proof on the second derivative. If I were specifically to ask you to prove it, then you would need to do that check. So anyway, our first number is going to be 24. Our second number is going to have to be 192 divided by 24. And that is it 8 or 6? I think it is 8.
I think it's 8, it's 25.
Yep, you're right. So our second number is going to be 8. And so these are going to be the two numbers that are going to meet all the requirements and give us that least value when we do the sum of the first plus 3 times the second. Any questions on that process? Okay, we will not be doing number 4. There might be one of these in your homework. You can challenge yourself and try it, but we're not going to cover it this year. Minimizing the distance. We have to use the distance formula and do a lot of things with that. So we're going to go on to example 3. Find the length and width of a rectangle that has the given perimeter and a maximum area. So this would be like we have a certain amount of fencing. We have 120 feet, let's say, of fencing, and we want to have a maximum area. Maybe we're putting in a garden, maybe it's something for a little pen for our dog, whatever. So if our perimeter has to be 120, so I want to call, it's a rectangle, so I'm just going to call this side X. If the whole way around my rectangle has to be 120, what are any two sides going to have to be? 60. So if this is 10, that's 50. If this is 20, that's 40. If this is 30, that's 30, and so on. So what would this side be then? Do you guys see why it would be 60 minus X? All the way around is 120. So any two sides are 60. So again, if this is 10, and they have to add up to be 60, this would have to be 50. So what I'm doing is I'm doing 60 minus this side. Okay? It's always going to work like that with rectangles. It's half the perimeter minus this side. Now, how do I find the area of the rectangle? Base times height, right? So I'm going to do the area is the base times the height. So I've got my two secondary equations. I've got my primary equation. I'm going to go ahead and multiply it out. What do we do next, Hannah? Take the derivative. So A prime is going to be 60 minus 2x. Set it equal to 0. 2x equals 60. X equals 30 is our critical number. Now I have to make sure that that's going to give me a maximum. It could give me a minimum. So what I'm going to do is I'm going to take my second derivative. The second derivative would be negative 2. That means we're concave down. If we're concave down and we have a critical number, is it going to be a max? Yeah. So we're going to have a max. And so we've proved it. And so the dimensions are going to be 30 by 60 minus 30 is 30. So what does it end up being? A square. Is a square a rectangle? Yeah, it's just a special rectangle. Is a rectangle a square? Sometimes, if it happens to be a square, but not if it's just a regular old rectangle. You guys were so like, no, but sometimes it is. Okay, good job, guys.